Alright, so we're here with Mike from Rotary Science. We got Cletus's engine for the mystery machine. Here's their rotors. This is Alberto's stuff. This is gonna be Cletus's stuff. So right now he's gonna be working on the 1/2-inch bolts.
Yeah.
Well, the studs.
A lot of guys will just like drill studs out, and the problem with that is like a regular twist drill bit will follow whatever hole is already there. So when you stack a rotary engine up, if you look like down the bore of each of those holes, none of them line up. They all mismatch. So if you're just drilling each plate or each housing, the drill just goes wherever it wants. So you end up having to drill the holes oversized to get them like to be able to put a 1/2-inch bolt through there. So what I do is first thing I'll go through with a 4-flute carbide end mill. This one's 12 millimeters, and each of these little blades on here is cutting. So I'll put a hole exactly where I want it in each of the locations we're going to put a stud. So 12 millimeters is a little bit undersized for the finished stud size. Then we're going to come back through with a single point micro adjustable boring bar. It's got this little carbide insert that moves in one direction, and it only makes one cut all the way down. So it makes a perfectly circular, perfectly round, perfectly straight hole. And the studs are just going to slide right in there with the same kind of fit that you get out of the dowel locations, and that's going to strengthen the motor.
We're going to be doing this on both Cletus's engine and Alberto's, so the point of it is to be able to hold more boost and not crack the rear plate. So this is gonna add, in theory, like 5 studs is the equivalent of adding 10 more dowel pins throughout the engine. So
stud material we're using is chromoly precision ground 1/2-inch. So it's 4140 using high strength nuts. We'll make the studs for these motors here in the shop. That way I can have quality control over every step of the process.
these are going to be Cletus's rotors, so we're going to do the side clearance right now. So this is for high RPM stuff. This is what the Repo had done to it, and you know that's why it's able to take such views at constant high RPMs.
So the way I do it is on the lathe between centers, so it's very repeatable. This mandrel here expands out as you push it down, so I'm going to use the bearing bore as the location to figure out if it's spinning true to the bearing bore or not. So all of this is precision machine stuff, and we're going to be driving it with the dog, so it's going to be as precise as we can get it. We're going to true the rotor up from what Mazda had at the factory. So we cut the base clearance into this rotor. This is going to keep the side seals from hitting anything. We're going to come back in here and clearance the tips also, like additionally. So that'll keep the corner seal from getting stuck in there for any reason.
of Cletus's engine. So we move on to the next ones, and he's gonna keep on working on the housings, the plates, do all the half-inch studs, and the last step will be balancing it when we probably will come and shoot that tomorrow. The next day, so we're gonna clearance. Well, you already side clearanced it. So he's gonna lighten the rotors. So this is gonna take weight off the side right here, and it's gonna make them lighter.
So the less weight that's moving around, the less forces are exerted on the bearings, and the longer your assembly is gonna last. So if it weighed nothing, it would last forever, theoretically.
I'm gonna show you the process of lightening rotors. You can see we took off a lot of material from that face. So he took out the clearance did on the sides for the side seals, still left enough meat for the side seals to hold in place, and then took off all this material and all that weight. So that's less weight getting thrown around on the while the rotor is spinning at 10,000 RPMs.
Yeah, this weight doesn't actually do anything for the rotor. It's just like not even structural, because it's got all the webbing inside of the rotor. So this is just a good place to take weight. So the later rotors, this is an S4 NA, but the later rotors, this is where Mazda took the weight out. So you can't take as much out of the FD rotors and the S5 rotors.
Yeah. But they took it out from the inside mainly.
Right, yeah.
So we're doing it from the outside because they're already made. So that's the first rotor. Now we got to flip it around and do the other side. And after that, the balancing?
Now after that, we're gonna do the super secret special scallop.
Scalloping, it flows better. So pretty much when the rotor opens on the port, the side seal is the first thing to open, so it hits a wall. So what he's gonna do, he's gonna scallop it, take away this wall, and make it flow better. It flows faster. So we'll show you how that looks in a second. We're gonna try a new scallop that opens up the port way sooner and should give us a lot of low end power. So given that this car is gonna go automatic 3-speed, we're gonna need all the low end we can get. So this is gonna help out a lot. We're gonna eat away at this wall and improve the flow going into the engine as the rotor opens up that port.
This is the scallop that I use for street ports, because bridge ports, since it opens so early, you just need a little piece of it. But a street port, it's opening it up way down here, so you need to drag it all the way back to about here to get the street port to open up sooner.
Lighten, scallop, and the next step is balancing the rotor by itself. So he's gonna use his machine right here and find how far off of balance this rotor is. So it's not just lightening it and scalloping and throwing it in the motor, you have to balance the motor.
So it looks like we gotta take 9.77 grams off on the left flank of the rotor and 7.24 on the right side. And since it's all in the same corner, this would really, if you just threw this in the motor like it is, it would shake the whole motor apart.
So pretty much a rotor bearing will piece out.
Yep.
We're gonna fix that on balance right now and test it out again and then balance the whole assembly.
after we get both of the rotors really close to being final balanced, we're gonna get them down to the same weight by taking some weight out of the heavy one, and we're gonna take that out of the center of the oil side of the rotor.
So that's weight matching. So that way if you flip and mix the rotors, it doesn't throw the balance off, because there is a front, there is a rear. Yeah,
this scallop you can only have a front and rear, but on like a normal assembly, you just want it so you can put whichever rotor, whichever spot.
Next step is balancing the rotating assembly as a whole. So these weights right here, they're called bob weights, and these are gonna simulate the weight of the rotor itself.
Yeah, since you can't clamp the rotor onto the eccentric shaft when you're balancing it, you have to simulate that weight. So this is the whole weight of the rotor, plus all the seals and springs, plus all the oil weight that's sloshing around inside of there. And that's all simulated in these weights. So Cletus's rotors are weight matched within a gram, so they weigh the same. So these both weigh the same. Alright, so this is telling me that his front counterweight is 41.6 grams too heavy, and his rear is 38.5 grams too heavy. We got to take some weight out on the milling machine here with the 3/8" drill bit.
So that's off each front and rear counterweight. We have to remove material. So his machine will tell him the setup right here, or will tell him where to remove weight right there. These are already factory weights that was removed, but you know, obviously it needs way more now. So we'll get the whole assembly balance, and that should be it after that. This is the final spin on Cletus's engine. So that's like the like pretty much anything under a gram is good.
Yeah.
So that's pretty good for us.
Yeah, we're under a tenth of the gram in the rear.
Yep.